is non-zero, and this is known as 0-point energy. We'll talk about it more later in some other context. But we were calculating averages or the expectation value. So we had calculated the average expectation value of position. Don't forget that your box is between 0 and L. So let me draw the box here. 0 and L. It is infinity here, potential energy, it is infinity here, and inside the box it is 0. So average X we had calculated, you remember, it must be the midpoint. What was the midpoint?
L by 2.
L by 2. So average X we had calculated this. What about average P of X? Actually, strictly speaking, you should put a hat there because these are operators. Yeah, this is 0. I told you this is 0. I did not show you explicitly, but I can show you explicitly because when you calculate Px average, I gave you the physical argument why it is 0. Now Px average is because these wave functions are normalized. Remember that wave functions are normalized, and the wave functions are given by 2 by L sine n phi x by L. So I have to integrate this 0 to L root over 2 by L sine n phi x by L. Because we are dealing with stationary state, we don't have the time dependent part. We don't need to write it again and again. That will cancel. So you have to take complex conjugate of that, and then I have to put the operator for the linear momentum, which is this minus IH cross d by dx, and that operates on 2 by L again sine. I am doing it for any arbitrary value of n, and I have to integrate it. Okay, and then what I can do, I can take this root over 2 over L and IH cross outside. This will give me 2 over L times minus IH cross. Okay, and then you have an integral of 0 to L, but you know that sine is a real function. It does not have any imaginary part. So the complex conjugate of that sine function is also the sine function itself. You have another sine function here. So essentially what you have here is sine, but remember that sine function is there, but you also have this. So this will operate on sine function, isn't it? What will the answer? If I differentiate sine, what do I get?
Cos.
Yeah, cos of x. If it is sine of x, I'll get something like cos of n phi x divided by L. But don't forget that this constant will also come out, isn't it? When you differentiate, it will be n pi by L into dx. Fine? You're following? Just say yes. I hope you are following. And then what you can do, you can just take this guy outside. But just see this thing very, very carefully. What is this? Whole thing. The whole thing is, this is something in the form. Yeah, it is something in the form, something like sine theta d sine theta. See, this integral is in this form, isn't it? Are you convinced that this is the way it is? How many of you? Because what is this part? This is actually d of sine whatever n pi x by L. So then, sorry. Then what is the answer? What is the answer then? Then the answer is going to be what? Your answer is going to be, you have to multiply this with, yes, it is half of, it is sine square whatever n pi x by L, isn't it? Okay, and then you have to put the limit between 0 and L. And what is the answer if I put the limit to this function? Tell me. What is the answer? It is 0. Are you convinced? Please write in the chat box that you can follow this is 0. Because again, it is something like sine n pi minus sine 0. This kind of structure, isn't it? This is also 0. So the answer is Px average is 0. Also have shown mathematically that Px average is 0. So, but then also you had another quantity, what is like Px square average. What is the answer? I'm not going to do it again because we did that in the last class in detail. What is the answer? Actually, you should be able to see from here. If I divide this by, multiply this quantity by twice m, that is the answer. The answer was n square h cross square y square by l square. Please check your note. Is it correct? What I have written here?
Yes, sir.
Yes. And then I am to calculate something like this, x square average. And what is that? I don't know because we have not calculated this, which we'll do in this class. Okay. So we want to calculate want to calculate the x square average. So essentially what I have here is, we have these quantities are there, but we still want to calculate x square average. Okay, and this one you have already calculated, so let us do this like this. And these are the things you need throughout. So let us calculate x square average. Okay. Now x square average, sorry for writing like this, but you know this is going to be, I can write down in detail, but I don't need to because we have done it so many times. What I have here is actually 2 by L will come out because we have root over twice, 2 by L twice, and then you have 0 to L dx, and this is multiplied with x square because it should be it is multiplied with x square, but let me write it down explicitly. You have sine n by x by L into x square. Okay, I think I'll do one thing. I'm going to now go to another page. I'm not going to do it here. Let us go to another page. Here. Right here. So your x square average is going to be 2 by L 0 to L dx sine n phi x by L into x square to sine n phi x by L. Okay, so essentially what you have here is 2 by L 0 to L x square sine square n phi x by L dx. Now, any suggestion? What should I do from now? From here? Any suggestion? You can write in the chat box. Or you can tell me, you can write in the chat box. Any one of you. What is the answer? Integration by parts. Yes. So I can do direct integration by parts, but let us do.
So before doing that, you can say 2 sine n pi x by L in the terms of 1 minus cos 2 n pi x by L.
That you should do actually, because if you
Yeah.
see the 2 sine square x or theta, whatever you do, it is 1 minus cos 2x. So this identity we are going to use. Okay, I am going to use. So if I use this, what I'm going to get here is 2 by L half, of course, 0 to L x square 1 minus cos n by x by L dx. Fine. So I'll write it down here. What I have here is 1 over L. The first integral is 1 over L 0 to L x square dx minus 1 over L 0 to L x square cos n phi x by L dx. Okay. What about the first term? Very easy to do because it's 1 by L. It is L cubed by 3. That's the answer. Fine.
Let's say cos 2 n pi x by L.
Yeah, sorry, I missed the 2. Very good. Yeah. So this is fine. This is L square by 3. This is very simple. And then I have 1 over L, and let us call this integral, you can name it. Let us call this integral I. Okay. So my definition of the integral is I. I am doing it in detail because we have people with background who did not have math in BSc, some of you. And also it is good to do once. So this is my integral, which is I. So now I want to evaluate this integral. So let us see how to evaluate this integral. You know that if you want to evaluate, you should remember this formula, u dv to uv integration by parts. See what happens, even BA students, let me take a break for a minute and you can answer. When you are in third year of your BS in chemistry and you are taking some courses outside the department, but you will see that in usual chemistry curriculum, you don't encounter math so much. So actually sometimes you lose the habit of doing math, isn't it? If you are doing BS in chemistry. What do you think, Devajit or Akash?
Totally agree with you. Most of the courses don't require such rigorous mathematics.
Yeah, but it is very simple. This is nothing anyway. But
I was keeping statistical mechanics in mind.
Yes. Okay. Anyway, this is not mathematics. If you say this is mathematics to mathematician, he will laugh. He'll laugh at you. This is some calculations. Okay, nothing. Anyway, so this integral we have to evaluate. So let us evaluate this integral. So the integral, you can see the integral. So I'm following this formula. So it is going to be x square, and if I integrate cos, what am I going to get? Tell me. Should I integrate? You have cos this, no? Which is what I'm going to get if I integrate cos? I'm going to get sine, isn't it?
Yes.
So I'll have sine. You can follow, no? Twice n by x by L into, remember, 1 over, what is that? 2 n pi by L. This should be the one, no? If I write down explicitly. Minus, if I make any mistake, please tell me. I can make mistake. Then you have integral from 0 to L. You have to do v du. You know that dv is cos. So v is again sine. So again you will have sine of 2n pi x by L. But the whole thing has to be divided by 2n pi by L. But then you have x square, but you have to take a differentiation of x square, isn't it? What is that? 2x. Yes. Is it fine? Now what about the first term, the surface term, or this one? Can anyone tell me what is the answer to this? Anyone? Write it down in the chat box.
0. It will be equal to 0.
Yes, because again you see that if I put L, x equal to L, you'll get twice n pi of sine, which is 0. Again, sine 0 is 0. So this part will give me 0. So I'm not doing it explicitly, but this is obvious. It will give me 0. So what I've left to it, the other part. So the other part is now, let me write it down very explicitly. Let me write down here. So the other part is you have a minus sign there. You have 2x there. You have 2n pi L is there. So I take this 2 outside and L will go there, and then you have 2n pi. But don't forget there is a minus sign, isn't it? And then you have 0 to L x times sine twice n pi x by L into dx. So now I have to integrate. I have to find this integral. So what I have here is minus L by n pi, and then again I do the same. Again I do integration by parts. Okay. Again I do integration by parts. So here now sine twice n pi x by L dx is your dv. So what will be the surface term? Surface term will be x times minus cos twice n pi x by L divided by twice n pi L. This is from 0 to L. Minus, again you have to integrate from 0 to L, but again you have to do v times du. So when you do v, you get another minus, which will make it plus. So you get cos twice n pi x by L divided by twice n pi L. And then I have to differentiate x, which will give me 1. So I have dx. And I should close the bracket. Fine? Is it fine?
Yes, sir.
Now, before we evaluate the surface term, the limit, where I have already put the limit, let me evaluate the integral. The second term. Can anyone tell me what is the answer to this integral? Can anyone tell me? Essentially, you are integrating cos x dx. What do you get when you integrate cos x?
Sin x.
Sin x. So actually, when you integrate, you will have this whatever L by 2n pi will come out. But then when you integrate this, you also get another L by 2n pi, which will be square. And then you have to put sin, yes, 2n pi x by L, but between the limit 0 and L, and the whole thing is 0. So the integral is 0. Okay, here, fine. Now what about the surface term? Let us see what is happening to the surface term. So now this one I can write it like this. So I can take twice n pi by L, whatever is there outside. Okay, I can take it outside. Yes, so if I, yeah, so essentially, and this minus, so essentially what I'm going to get, I am going to get something like L square by twice n square pi square. These are the constants. Huh? This is fine. This is fine.
Yes,
These are
sir.
the constants. Okay. Okay, and but now I have to put the limit. Now the limit is okay. This bracket, and the limit is when I put L. L, I have already taken the minus sign out. So the first term will be L cosine of twice n pi L by L minus 0. That is the term, isn't it? Are you
Yes,
convinced?
sir. Yes, sir.
So what is cosine? This L and this L cancel. What is cosine twice n pi where n is an integer?
1.
1. Okay. So essentially you have L times L square. So you have L cube divided by twice n square pi square. Fine. So now I go to the next slide, and or maybe I can be here. So essentially what I have here is L square by 3, your x square average. I can do it here only. And then you had 1 over L times I. And what is the value of I? I is L cube by twice n square pi square, which I get it from here. So what is the final answer? What is the final answer? So basically you have L cube by 3 minus, not L cube, sorry, L square by 3 minus L square, it has to be L square because it's square of a distance, by twice square pi square. Okay, and I'll just, I can take L square common. If I take L square common, it is 1/3 minus 1 by. So I also get x square average. So now let me see what we have, what you have gathered so far. You have gathered these things. X average is L by 2. X square average is, just you have calculated this. If you take L square common, then it is 1/3 minus 1 by 2 n square pi square. I hope that was the expression. Yes. And we had px average, which is actually should put this px average, the cat. And this one was n square h cross x square pi square, isn't it? So we have all these things. Now let me tell you one thing, there is something called, if you calculate say some average of some quantity, for example x, then I can also always calculate an quantity like any instantaneous value of x minus the average value of x, make a square of that, and then average this. Okay, I let what L to what? Yes.
The average value of these.
Oh yeah. So this quantity I'm calculating x minus x average, and this has a name. This is in case of x or whatever. In general, this quantity has a name. This is called mean square deviation. You have encountered this. Where did you encounter this? Also known as variance. Where did you encounter this? Any idea? Can anyone write it down in the chat box? Error calculation. Yes, very nice. So let us calculate this. Now if I expand this quantity, what I'm going to get within the angular bracket, I have x square minus 2x x average plus x average whole square. Now again I'm taking an average of this, so this will give me x square average minus, now this quantity x is already average, this one is already average, so I have to average over this, so this will give me x average times x average when I take this inside, plus x square x average square. So essentially what I have here, I have x square average minus, see, this will give you 2 times x average square plus x average square. So this will give me x square average minus x average square. And since x is real in this case, whatever we are calculating quantum mechanics or in reality also is real, this quantity is real and positive. It could be 0, of course, and must be greater than equal to 0. Are you convinced that this is real and greater than equal to 0? It has to, because it's a square of a real number, isn't it? It's a square of a real number. Okay, this is a square of a real number, so it has to be positive. The lowest value possible value is 0. So essentially it tells you that okay, this quantity is greater than equal to 0. So actually it is denoted by a symbol sigma x square. Not sigma x square, but sigma x square actually. And then I can define another quantity which is called sigma x, which is your root over of sigma x square, and this is, you have a name for this. Any idea? What is the name? This is called
Standard deviation.
Standard deviation.
standard deviation, or you find?
Yes, sir.
And in this case, in case of x, this is going to be root over of x square average minus x average square. So similarly, for momentum, I can define this root mean square deviation or standard deviation, and this is actually known as uncertainty in quantum mechanics actually. So whatever, this is also your delta x or the uncertainty. Okay, I think some of you knew this. And then I can calculate sigma of px. What is the answer? Your answer is, you know that it has to be something like px square average minus px average square. Sometimes I put the hat, sometimes I don't, but I think you should put the hat all the time. Okay, this is fine. Any question? This is quite straightforward. This is the uncertainty in the momentum of the x component of the momentum, and this is the uncertainty in x. Since we have one-dimensional system, we have only x direction. So now can I calculate this sigma x? Yes, I can certainly calculate for particle in the box, because your sigma x, can you tell me what is the answer? Sigma x is going to be square root of, what is x square average? Whatever this quantity, no, huge quantity, minus this. So what I have here is your L square by 3 minus L square. If I make any mistake, please tell me. Minus x average square. What is that?
Square by 4.
Yeah, 4. And maybe I can simplify this. If I simplify this, what I'm going to get? If I simplify this, what I'm going to get? Tell me.
L into root over of 1 by 12 minus 1 by 2 and so by so.
Yeah. So basically, what you are going to get root over. Let me keep it inside and do it. So L square by 3, 1/3 minus 1/4. What is the answer? It should be L square by 12, isn't it?
Yeah.
L square by
Minus L square. We will simplify it further. And what is sigma px? Sigma px is not very difficult to calculate, because you have px square average is this and px average is 0. So essentially you have n square h cross s square pi square by L square. Okay. And all these quantities are positive. So what is the answer? It is actually n h cross pi by L. Are you convinced? Please tell me if I have done any mistake. Any mistake? Do you see any mistake here?
No, it's okay.
Okay. So now I am calculating the what is that called, the product. Now the product is going to be, let me do it here. The product, wait, yes, sigma x into sigma px, and this is going to be, okay, let me write down sigma px first. Sigma px is n h cross pi by L, and then you have sigma x. Now I can always take what is that called, L square common. Okay, I can always take not only L square, I can also take L square by n square pi square common inside. If I take this, what I'm going to get here? Tell me. I'm going to get n square pi square by 12, I think, minus, tell me, half. Please tell me if I am doing anything wrong. Am I doing anything wrong? Any mistake do you find?
no,
No, sir.
If there is a mistake, tell me. So there is no mistake, but I can always
It's
take,
okay.
yeah, I can always take this L square by 4 n square pi square common. If I take this, what will go inside? This 12 will become, tell me, what will happen to this 12? This will become 3.
3.
And what will happen to half? Follow. Half?
2.
Half,
2.
we have to multiply.
2.
Yeah. Yeah, very good. So what I'm going to get? I'm going to get 2. And then this, I love to use different colors. But then this quantity is actually a square of some real number. I can take it outside. What is the answer then? If I take it outside, so I had something like n pi by L. Also had h cross, but when I take this one out, you have L by n pi. Also you have 2, isn't it? And then the h cross was there. Fine? Is it fine?
Yes, sir.
Yes.
Then can I do this? And if I do this, what is the answer? The sigma x into sigma px is equal to h cross by 2 multiplied by something like n square pi square by 3 minus 2. You remember what was uncertainty? It says that delta x, delta px is greater than equal to h cross by 2. And your delta x is your, essentially what you had, sigma x and sigma px greater than equal to h cross by 2. Okay. Now you have to prove that whatever is multiplied with h cross by 2 is greater than 1. This is your final answer. Sorry. And are you convinced that whatever inside that root, even after taking the root, the quantity is greater than 1? How many of
Yes,
your...
sir.
Yes. So what is the lowest possible value of n?
1.
1.
1.
Yeah. So the ground state is 1. You cannot go below that. So even in the ground state, when n equal to 1, what is this quantity? This is pi square by 3 minus 2. And can anyone tell me what is the number? Anyone has a calculator? Anyone has a calculator with you?
So something more than 3.2 pi square by 3.
Yeah, pi is like 9 point something, but then you have to take a square root, no? 3.28 minus 2, 1.28, and square root of that. What is the answer? So actually I can tell you the answer is something like, I had done it, nothing else, it's 1.13,
1.134.
something like that. So greater than 1. Okay? So basically what you see here, and if I go to higher value of n, it is obviously it's higher. Value is even greater. So the lowest possible value of n is 1, and for that state, your sigma x times sigma px is slightly greater than h cross by 2. So essentially, you cannot prove, but you are actually showing that your Heisenberg's uncertainty principle for particular box problem is not violated. It cannot be violated. It is also consistent with Heisenberg's uncertainty principle. So how many of you had this in your BSc or in PH 107? Was it discussed in PH 107? BS students, I'm asking you. Yes. Okay. So Krishnendu said, okay, it had PSC, but not everyone, I'm sure. Not everyone had it. Okay. So this is fine. So the next thing we'll see that if I told you that your wave function was normalized, but if I ask you to calculate the integral like this, that if I take psi n for complex conjugate of that for this state multiplied with psi m, this m is not mass, although the same notation. and then I integrate this between 0 and L. What is the answer? Can anyone tell me what is the answer?
0.
0. Yeah, it is not very difficult to show. Just I'll do it very fast. So it is what you're going to get. You're going to get 2 by L, 0 to L, sine of n pi x by L times, because the complex conjugate of this real function is the same function, and sine. Yes. Yeah, we are assuming that n is not equal to m. For this. And this thing, you know, this is 2 sine A sine B, or 2 sine theta sine phi. You remember what is 2 sine theta sine phi? Can
Sine
anyone tell me?
theta.
It is actually, let me tell you, 2 sine theta sine phi. I'm giving you everything in the node. It actually is cos
A minus B by 2.
not theta minus cos.
Minus cos theta plus.
This is a formula, trigonometric formula. Okay.
I guess it's by 2, sir. Theta minus pi by 2 and theta plus pi by 2.
Pi by 2. Are you sure? No. I think sine theta sine phi is half of this, isn't it?
Yes, sir.
Yeah. So I can take the 2 outside, but anyway, what I'm going to get is 1 by 2, doesn't matter, 0 by L, and then you have this quantity, cos of n minus m pi x by L minus cos of n plus m pi x by L, and this one will give you 1 over L. And you know, if you integrate cosine, what I'm going to get? Cosine, if you integrate, what do you get? What is the answer? What is the integration of cosine? It is sine, isn't it? We are going to get sine. I know it is very boring. Let's finish it very soon. Just look at it. What I have here is and what are these terms? What are these terms? This is 0.
Yes.
And we have done it so many times here. So the whole thing is 0. But if n equals to m, then what is the answer? The answer is 1, because then you are normalizing, no? It's normalization. So in general, I can write that, okay, when I write this integral is dx sin star x sin x sin x from 0 to L in this case is actually delta nm. So delta nm is such that delta nm equals to 1 if n is equal to m. This is equal to 0 if and this is called Kronecker delta, I think. Please check the spelling, I think is correct. Okay, and this is essentially what it tells you, that all these psi n's form from an orthonormal set. It basically means that each of these size are, each of them is normalized, and what else? And if I take two sides of different quantum number, then that integral is 0. Then also orthogonal. Why it is so? Can anyone tell me? This is a consequence of something which we have not discussed again in detail, which we'll do in the next class. This is because the Hamiltonian for the particular box is Hermitian, isn't it? And since H is Hermitian, the eigenfunctions of H, this eigenfunctions of H form an orthonormal set, isn't it? Are you convinced? We have not proved it mathematically, but we are saying, okay, your Hamiltonian, whatever you do in quantum mechanics, is Hermitian, the operator. So these are eigenfunctions of that Hermitian operator. So all of them, and each of them is normalized, so they form what is known as an orthonormal set. Okay. So one more thing is there is something called completeness, which I should mention. Now completeness is something like this. You have a box of 0 to L, and you have this orthonormal set eigenfunction. So I can choose any function in that interval 0 to L. I can choose any function in that interval 0 to L. So I choose any arbitrary function, say f of x, in this interval. This function, any function between 0 to L, with this Hamiltonian, this function can be expressed as a linear combination of, like this. I have this orthonormal set, no? So any function you give me within that interval, I can express that function in terms of this orthonormal set. I take linear combinations of this orthonormal sets, and these are coefficients C1, C2, C3 like this, and that will give me any function in f of x. Okay, choice of C1, C2, C3, the set will tell you what is the function. Essentially the set Ci, where I goes from 1 to n, where n is infinity. Actually, you have infinite number of functions possible. So any arbitrary function can be expressed as a linear combination of these orthonormal functions. This is called completeness. So basically, this is this form, this eigenfunctions of the Hamiltonian H. They form an orthonormal complete set. Okay, it's a complete set and orthonormal, and this is a property of a Hermitian operator. Consequence of an operator which is Hermitian, and these are eigenfunctions of this Hermitian operator. Okay, is this clear? Is this clear? Any question? Because we are going to discuss this in detail in the next class. So in the next class, we are going to start dealing with vector space and the properties of operators. should do. One more thing I want to mention here, that you say we have seen that your sigma is times sigma px, the position and conjugate momentum. This is the position x and this is conjugate momentum. This is greater than equal to h cross by 2 that you have seen. So what is the position operator? It is x hat, which is the multiplication, and px is minus h cross del x. You can write it in this case actually ddx. So let us take any arbitrary function. Say I take a function f of x and operate x on that. What I'm going to get? I'm going to get nothing but x times f of x. It's getting multiplied with x. And now if I operate another, now if I take this and operate px on this, essentially I take px operator and operate on this. What is the answer? The answer is your px is minus ih cross ddx, and you have x times f of x. And what will be the answer? Minus ih cross is a constant, so it does not matter. But when I operate ddx on this, what I'm going to get? I'm going to get is a product of two functions. The first time is going to be f of x because times 1 plus x times dfx dx. Are you convinced? This is nothing so difficult. And you see that in some books, and I also prefer this, whenever you take a derivative with respect to position of a function, you can write it like this. How many of you know this notation? Sorry. How many of you know this notation? I think everybody knows. Yes. Yeah, because this thing is nothing but this thing. Okay. But again, I can do the operation in the reverse fashion, such that first I operate px on f of x, and then I operate x on that. So this will give me what? This will give me x. Now, when I operate px on f of x, that will give me minus ih cross into f prime x. This is fine because ddx of fx, because your px is this minus h as a constant, so take a derivative with respect to x of fx, which is f prime x. And now if I write down this quantity, for example, x px, I have defined an operator, okay, minus px x. This is an operator also, no? The whole thing operate on f of x. What is the answer? The answer is as follows, because I have already know, because I have already done x px. X px will give me x times minus ih cross f prime x, and px x operating on fx, I know it is minus of this quantity, which is minus and minus will combine, it will give you ih cross fx into plus ih cross x f prime x. Can I simplify this? Can I simplify this? Yes, because you see this term and this term, they are just the same, but only the signs are different. Magnitudes are same, so they will cancel. And when they cancel, what you have here is this. So this quantity on your hand, you have ih cross time f of x. And the quantity in the bracket xpx minus pxx, it is too long to write so many times, and people usually use this square bracket, within that square bracket x comma px, and the whole thing is operating on f of x, and that gives you this. And this is called commutator. In quantum mechanics you'll encounter. You know this? How many of you know this? How many of you? Yeah. Okay, so here this x px commutator, if I don't need to write the function itself, it is actually IH cross, of course not equal to 0. And it tells you that if two operators x and px, x and the operator for its conjugate momentum px, they do not commute. Yes. So essentially they don't have any common eigenfunction. And this is actually another way of saying uncertainty, isn't it? Why? Because they cannot be determined simultaneously. Okay. So your x and px, cannot be determined at the same time without, there is always an uncertainty associated with its determination. This is another consequence. But you will see that when two operators commute, for example, in general, if I have a situation that two operators A and B, they commute, which basically means the commutator is 0, then they will have a common set of eigenfunctions. This is also very important in quantum mechanics. This is very important in quantum mechanics. And now I want to discuss one simple thing, and then we'll revise few things. First of all, if you see carefully that we had a box of length L, but it's from 0 to L. But instead of that, if I have a box of length, say same length L, but from between L minus 2 to L plus 2, sorry, minus L by 2 to plus L by 2, and if I draw the wave function, you can do the quantum mechanics, you will find the wave function looks exactly the same, like this. First one, second one is like this. Sorry, it will not go outside. Bad drawing. Like this, or sorry, maybe I want to do it like this. Yeah. Okay. This is your psi 1, this is your psi 2, and this is your 0. So what about the potential in this? So now consider this case, not this one. What is the potential energy? V of x. It is 0 inside. Earlier, but now the limits have changed. So what should I write here? Your limits are what? Minus L by 2 and plus L by 2. Are you following? Please write down in the chat box. Essentially, we are doing the same problem, but we are now have a different coordinate system. Essentially, it's just the same problem, but with a different coordinate system. So basically, V is 0 between this, and it is infinity otherwise. So what does it mean? So essentially you have, so around this point, if I write down this, I draw this, for example, let me draw this. So if I draw a line like this is your 0. Not so around that point, the potential is what? It is symmetric around 0. So if I take V of minus x, what is the answer? Can anyone tell me here? V of minus x means on the left side of 0. Minus x means anything on the left hand side of 0. Plus means anything on the right hand side. In this case, what is the value? Vx? No, V of minus x. No. The V of minus x is nothing but V of x. That is the question, whole thing. Because it is symmetric around 0. You understand? It is infinite. Then it becomes at minus L by 2, it becomes 0. From minus L by 2 to plus L by 2, it is 0. Again, it is infinite. So it is actually V of minus x is V of x. So it is symmetric. Or even function of x. Okay? Are you convinced in this case? If you are not convinced, please tell me. Okay? And what about the wave function? What about psi 1? I did not write the expression, but just look at the picture. Psi 1 is also even, isn't it? Because psi 1 of minus x is equal to psi 1 of x. Remember, we have shifted the coordinate system. Your 0 is here. So your psi 1 is symmetric around 0 because on the left of 0 and on the right of 0, it has the same positive value. So psi 1 of minus x is psi 1 of x. Okay? So what about psi 2? Psi 2 of minus x, can anyone tell me what is the answer? What is psi 2 of minus x? Now psi 2 means, this is your 0 actually. Okay, this is not very well drawn, but this is your 0. So on your left and right, if I go from left towards the left from that point, your psi of x is positive. On the other hand side, it is negative. So basically, this psi 2 of minus x is actually minus of psi 2x. This is odd function. So it is symmetric, anti-symmetric, symmetric, anti-symmetric, like this. Because if I go to the next, which I have not drawn, psi 3, what will be the property of psi 3? Psi 3 of minus x is going to be what? Can anyone write down? Psi 3. What is the answer? Psi 3 of minus x. Even function. Yes. Others should also write, not only few well-known names can see. Anyway, so that is okay. Now what about the Hamiltonian? Your Hamiltonian is h is equal to minus h cross square by twice m. So your Hamiltonian is also depends on x. And if I take h of minus x, what is the answer? I'm just doing this operation. What is this? The first term is going to remain the same. And this one I know is e of x, which basically tells you what? H of minus x is equal to h of x. Okay? Now, I had this eigenvalue equation, h operating on psi n x. What is the answer? N times psi n of x. That's the answer. H Hamiltonian operating on psi n of x gives you the same wave function back multiplied with a constant En, which is your energy. And this should also be valid for minus x, because that is for any value of x. So if I make x to minus x, it should also be valid, isn't it? Are you okay? You're fine. Are you fine? If you are not fine, please tell me. If you are not fine, please tell me. And what does it tell you? Basically, it tells you that, okay, if I operate H on psi n of minus x, that will give me En times psi n of minus x. Okay, isn't it? But at the same time, if I operate, so basically it tells you, essentially, if you think carefully, it tells you that ideally your psi n of minus x has to be equal to psi n of x. Okay, or you can multiply this with a constant c. Have you done this earlier? Have you done this earlier? Now it is your duty to show, which I'll ask in the next class actually, that how it is coming. And what are the possible values of C? This constant C. Yeah. So Ganpat Patel says this constant could be plus or minus 1. How it is possible? Ganpat, tell me.
Hello, sir. Am I audible?
Yeah.
Sir, as we can see symmetry-wise, xi1 in xi1 minus x equal to xi1 x. So for n equal to odd numbers, the c will be plus 1, and for n equal to even numbers, it will be minus 1.
Yeah. So don't like this. No, it is even more general than the particular box in this case. So what I have here is your Hamiltonian. If I make h of minus x, and then I operate this on psi n of x. Okay, so that should give me En. This is true, no? So if I change your Hamiltonian to x to minus x, it does not mean anything. It remains the same. This can operate on your psi n of x, and it will give you your thing. So I can also do the same thing. I can actually operate your h on psi of, which I have written here, psi n of minus x, and that gives you En times psi n of minus x. So we have this equation, see this equation, and also you have this equation. Look at very carefully. What is this? Same Hamiltonian operating on psi n of x give you n times psi n of x, but psi n of minus x is also an eigenfunction. You understand the point?
Yes, sir.
Everybody should follow that this also an eigenfunction. You understand what I did? I said, okay, this should also be valid for minus x. So I just change everywhere minus x. Okay, so I put, so actually I put it here, psi n of minus x operating on this, you see this. But I know that h of minus x is equal to h of x, isn't it? And I have this equation. So I have this equation, and I also have this equation. And because in both the equations, same Hamiltonian operating on a function gives you the same function back multiplied with the same eigenvalue En. Okay. But what is there? So the thing is, if psi nx is an eigenfunction of h, psi n of minus x is also an eigenfunction of h. It basically tells you that it's possible only when your psi n of minus x is equal to psi n of x. This is one possibility. Or you can multiply this with any number, isn't it? Are you convinced that you can multiply this with any number? So if you multiply this with any number, say for example, so this number is c. So this is also true. Now my question is, how do you calculate the value of c? Any suggestion? So if one function is an eigenfunction of that operator, if I multiply that function with any number, that still remains the eigenfunction of that operator, isn't it? Are you convinced? This is very simple.
Yes, sir.
A constant, you're multiplying with a constant, does not matter. So why I'm saying that constant is c. Now I am asking you, what are the possible values of this constant c? So I'll do that. The way it is to do is just like this, because what I can do, your psi n of x is actually, what is this? It is psi n of minus of x. Are you convinced? Can I write it like this?
Yes, sir.
And what will be the next step then? Psi n of x is actually psi n of minus of x. I'm just putting two minuses inside. It's a trick. Okay? Are you okay? Then what should I do? So this is again equal to what? Psi n of x is equal to this, and this is nothing but c times psi n of minus x, because I know this. Yeah, if I put x here, it will be minus x here, isn't it? C times psi n of minus x, and that also tells you that it is nothing but psi n of minus x. I know what is this. This one, we use c square psi n of x. That tells you what? C square is 1, or c is what? What are possible values of c? What are possible values of c? Yes.
Plus minus
The
1.
possible values of c are plus minus 1. So what does it tell you? Essentially, it tells you that your Hamiltonian is symmetric. Essentially, your potential is symmetric. Then your wave functions, your eigenfunctions are either symmetric or antisymmetric. That is what you see in a particular box. When you shift the origin, it's symmetric, antisymmetric, like this. And this is another property, and this happens only when your Vx is symmetric, because your kinetic energy part is always symmetric. But if you choose your potential energy symmetric, then your wave functions are symmetric and antisymmetric. Can you give me another example other than particle in a box with zero origin? with between minus L by 2 to plus L by 2. Any other example? Can you give me any other example? Anything which you have learned already? Harmonic oscillator. Remember? Yes. What is the potential? Half kx square is symmetric, no? X square. So if you make x to minus x, it is still the same. There also, if you see, you will have Hermite polynomials, and the wave functions just are symmetric, antisymmetric, like this. This comes because of the property that your Hamiltonian, the potential energy, is symmetric. That ensures that your eigenfunctions are either symmetric or antisymmetric. So it comes in the order like symmetric, antisymmetric, like this. Okay? This is the property of your Hamiltonian, the consequence of that. Okay? So one more thing I'll just do here, which I have done it in the previous class, but I did not do it explicitly, which I want to do it now, and that is the last thing I'm going to do. And in the next class, we'll briefly mention particle in 3D box, very briefly, maybe 10-15 minutes, and then we'll start working on this linear vector space. So please come. I don't think many of you know what we're going to do in the next class. And tomorrow I'm going to send you a set of assignments. Okay. Now, I told you that if I take psi1 times exponential of minus I1t by h cross plus psi2 exponential of minus I2 by t by h cross, and I'm calling it say phi, whatever. And this is not stationary state, not a stationary state that I mentioned in one of the classes, no? Remember that I mentioned that in one of the classes. Why? Can anyone tell me why? Because if I calculate 5 star phi, you'll see it is time dependent. So explicitly, if you calculate, you will see it is something like psi1 exponential of minus I1t by h cross plus psi2 exponential of minus I2t by h cross into star of this multiplied with psi1 to the minus. See, I could have put here C1 and C2. I did not put. I just chose C1 and C2 as 1. And actually, it is possible you can normalize the whole thing just by putting 1 over root over 2. Okay, so I can put 1 over root over 2 here, 1 over root over 2 here. How many of you know this? We'll do it later. Which is, so essentially what I have is half. And if I expand this term, I'm going to get terms like this. This one multiplied with this one. I have to take a complex conjugate of that, which will be like psi1 star. And complex conjugate of this is exponential of plus I1t by h cross, isn't it? So the first term is the complex conjugate of this is, if I take a star of this, I'm going to get exponential of plus I1t by h cross, isn't it? So the first term will be this one multiplied this one will give you only psi1 star psi1, because this exponential of plus I1t by h cross and exponential of minus I1t by h cross will cancel. Similarly, this term multiplied with this will give me what? It will give me psi2 star psi2. Are you following? Please write down in the chat box. Okay. And what are the other terms? This one multiplied with this one, what will give me what? It will give me psi2 star psi1, but then I have exponential of minus I by h cross. Then I have E1, sorry, E2 minus E1. Is fine? And what is the next term? Next term is going to be this multiplied with this. This will give me psi 1 star psi 2 e to the power of, say, I can take I by h cross common. Then it will give me, it will give me e minus, which one is which one? Tell me. E1 minus E2 or E2 minus E1? Tell me. So this one has given me this one multiplied with this one has given me psi 2 star psi 1. So E2 comes with minus and E1 comes with, E2 should come with plus. So essentially it should be like this, isn't it? What about this? This is like this, or like this. Please check whether this is correct. I think this is correct. So this, but I have time here, t, don't forget time. So what about this? This is actually function of time. These are oscillatory function of time, isn't it? So as a result, your phi star phi is an oscillatory function of time. Are you convinced? Please write it down in the chat box, and I'm going to show you one. So there's something called Mathematica. We have written a code here. So you can see that when I take this phi, which is a combination of the psi 1 plus psi 2, where psi 1 is this one. You can see it is written like this: square root of 2 by L sine phi x by L times the exponential of this. And if I do this, and then, so if I go here, when time is zero, so I can do it here again. Yeah. So this is where when the time is zero, can you see? This is your probability density, your phi star phi. Can everyone see this? This is phi star phi. Please write down in the chat box that you can see, or you can tell me. And now as the time progresses, this is going to be time dependent. So it is going to oscillate. So I am just plotting the real part of this psi star psi because it is exponential of I. So I can decompose into cosine and sine. I am plotting the cosine part, and you see that, okay, psi. Maybe I'll just, yeah. So can you see this? So essentially this is the probability density of a state which is non-stationary. This is not stationary. The probability density actually oscillates as a function of time. Can everyone see this animation?
Yes.
Can everyone see clearly? So this is called non-stationary. And how you can create this non-stationary state? You can create because you can take a molecule and then expose that molecule to an electromagnetic radiation. And that is exactly what you do in case of spectroscopy. You shine light. And when you shine light, you can create molecule you can create a non-stationary state. You can put the molecule in a non-stationary state, and the probability density or the probability will oscillate as a function of time. Okay. So with that, you can see this animation. With that, we'll conclude today. I think we had a very long class, so we'll conclude. And I am now going to stop the recording. Thank you.